So Janet and Roy are ice skating. At one point, Roy stands still and Janet glides up to him from behind and grabs him by the shoulders. Janet's velocity as she glides up to Roy is 5 meters per second. And together, they glide off at a velocity of 2.2 meters per second in the same direction. Roy has a mass of 65 kilograms. Alright, so part 1 of that is state the law of physics that applies to this situation. Alright, so if we're talking about masses and velocities, alright, and we're talking about a before and after, it's most likely going to be conservation of momentum. Part 2, calculate Janet's mass. Alright, let's write down what we've got first. Alright, so we have the mass of Roy, which is 65 kilograms. We have Janet's initial velocity, which is 5.0 meters per second. We have the final velocity, which is 2.2 meters per second. Alright, and we're wanting to find out the mass of Janet. Because momentum is conserved, the final momentum is going to equal the initial momentum. So we're going to need to expand this. Alright, so the final mass and the final velocity is going to equal the mass of Janet times velocity of Janet plus the mass of Roy times velocity of Roy. Okay. Now, we know that Roy is stationary. Okay. So this velocity of Roy is not going to be anything. Alright, but we have 2 masses that are going to be in here, so we need to in fact expand that again. Okay, so what it's going to look like is the final velocity is the mass of Janet plus the mass of Roy. Alright, so that's the final mass, there's our final velocity, alright, and that is going to equal the mass of Janet times the velocity of Janet, right? That's 0 because the velocity here is 0, his initial velocity. So that one we can cancel out. A final velocity of 2.2. We have the mass of Janet. We have the mass of Roy. All right. Then we need the mass of Janet and her initial velocity, which is 5.0. Okay. So what we can do is let's expand this first. So let's try and get rid of as many numbers as we can. Alright, so we're going to have 2.2m plus 65 times 2.2, which is going to equal 143. Alright, and that equals 5.0 times the mass of Janet. Alright. So what we need to do is we now need to get the mass of Janet onto the same side. Alright, so we have 143 is the same as this. Alright, okay, so we then need to simplify this down. So 5 minus 2.2 is 2.8. Alright, and then all we need to do, the mass of Janet is 143 divided by 2.8. So the mass of Janet is going to equal 51.07 kilograms. Alright, and our last step, just to check, is to make sure we've got the right number of significant figures. Alright, so we've got 2 here, 2 here, and 2 here, so we're definitely in 2. So it's 51 kilograms to 2 significant figures. Alright. That was a bit of a tricky one. Alright, needing to be able to factorise and expand those brackets. Part 3. Explain why you can use the assumptions you made when calculating Janet's mass. With this conservation momentum, what are we assuming? When we are looking at conservation of momentum, we are assuming there are no external forces. Okay, so conservation assumes no external forces. And the reason we can assume that is because they are ice skating. Alright? So there is little to no friction when ice skating, and friction would be the only external force. So because there's no friction, there's no external forces, momentum is conserved. There is no friction, there are no external forces, so momentum is conserved. These two here are merits, and this one is our achieved. Part B. Okay, after removing her skates, Janet jumps down to the ground from a high bench. Write a comprehensive explanation of what Janet needs to do while she's landing so that she does not hurt herself. Use a formula to explain your answer. Okay, so what we're looking at here is impulse. Okay, we need to think about the force that the ground is going to impact onto Janet. Okay, so we need to talk about force. Okay, we need to talk about something that she's going to do to reduce that force. Okay, so we're going to also talk about time. All right, so this question is about impulse. Okay, so how can we increase the time? Well, the easiest way, and we all do it instinctively, is to bend your knees a little bit. All right, so Janet should bend her knees as she lands. Okay, so bending your knees, this increases the duration of the impact. So by increasing that time, all right, by increasing this, we can decrease force, okay? This decreases the force she will feel because the momentum remains the same. All right, her mass will stay the same, and the velocity that she has just before she reaches the ground will also be the same. So her momentum must stay the same. All right, so use a formula to explain your answer. Okay, so we have change in P equals force times change in time. All right, this stays constant, increase time by bending knees. So force must decrease. This is actually your excellence question. All right. So for B, for achieved, you just needed to give a suggestion of what Janet needed to do when she was landing to not hurt herself. Okay. So saying something about bending her knees. All right. For merit, you then needed to say that she needed to bend her knees and that this increased the stopping time, so decreased the force. All right. The excellence part is saying that increasing time decreases the force because momentum is going to stay the same whether or not you bend the knees. Part C. When Janet jumps down, is her momentum conserved? Okay. All right. So what are our conditions for conservation of momentum? For momentum to be conserved, you must have no external forces. All right, so momentum is not conserved because there are external forces. All right, and that external force is gravity. So remember that gravity is a force and an acceleration, all right? So the force is her weight force, all right, caused by that gravity, okay? And that is just an achieved question. So you need momentum is not conserved because there are external forces, which is gravity, all right?